Hello everyone, today I am going to introduce a 4S BMS module with a balanced feature for lithium-ion batteries. I will first introduce briefly what a BMS is, and then review some of the specifications. And finally, I will show you some test results, showing the capabilities and limitations of this module. So, let's have a brief introduction on what a BMS is. BMS is Battery Management System in short. This system protects the battery during charging and discharging. You can connect multiple batteries in serial and in parallel configurations. There are simple BMS like this one shown in the left, and more sophisticated ones like the one on the right. And this is the one we are going to review in this video. The model name for this BMS is BMS40A4SB, which supports 4 cells in series, up to 40 amperes charge and discharge, with a balancing feature. Let's take a look at the specifications. The charge voltage should be in the range of 16.8 to 18.1 volts. The current for charging and discharging should be limited to 40 amperes for continuous operation. Overcurrent protection is activated in the range of 70 to 90 amperes. Protection is also provided per cell basis. When charging, this BMS protects the cells when the voltage exceeds 4.2 volts. When discharging, it protects the cells by disconnecting the path to the load when the voltage decreases to 2.4 volts. Balancing between the cells starts when a cell voltage exceeds a voltage of 4.17 volts to 4.23 volts range. This means that this BMS supports balancing between the cells when it is being charged. The configuration for this module is as follows. The charge and discharge port is connected to the charger when charging, and to a load when discharging. 4 groups of cells can be connected this way. Each group can have more than 2 rows of cells as shown here in the figure. Now let's see how it is charged when the voltage of one of the cells is substantially lower than others. I connected 4 battery cells in series, with the 4th cell having 3.36 volts. The charge voltage is 16.9 volts, and the current is limited to 2 amperes using a CV regulator. This is the charge result. The voltage of each cells gradually increase up to 4.2 volts, and the current decreases from the initial value of 500 mA to 0 ampere when the charging is complete, with some switching on and off occurring during the final stage of charging. As a result, you can see that the 4th cell has been quite well balanced to the other cells, with a maximum voltage difference of 0.043 volts. Now let's see how it performs when it is discharged. I used 2 1-watt LEDs with an LED driver to provide a constant current of 150 mA. The initial voltage of all cells were almost identical. During discharge, the current maintains a value of 150 mA until a certain cell has been fully discharged. The final voltage value for each cell is shown in this table. You can see that the 3rd cell has been dropped to a negative voltage. But actually it is not the battery itself showing a negative voltage. The battery has been shut down due to the built-in protection function from the battery showing a voltage of 0 volt. The negative voltage is coming from the BMS itself, when the cell voltage is below threshold. Also, it is evident that this BMS module does not support balancing during discharge. One more thing to note is, cell number 3 and cell number 4, discharged faster than other cells. I purchased these batteries together, and the initial voltage measured from these batteries were identical. It can be due to the battery itself, but also the BMS can be causing this unbalanced discharge. So let's find out by performing a discharge test after swapping the positions of these batteries. After swapping the position of the battery from cell 1 to cell 4 and cell 2 to cell 3 and so on, the result looks like this table. As you can see from the table below, the battery was the reason for the different discharge rate. And also, this time the BMS detected the low voltage from cell 1, and shut down the connection to the load, protecting the battery. That's why we couldn't see the negative voltage we've seen in the previous test. Finally, I would like to find out how the balancing works. According to the datasheet, the balancing starts at a voltage of 4.17 volts. So I removed one battery from the configuration, and connected a power supply to this cell position, with a voltage of 4.3 volts. Observation point would be, will it charge other cells? Or will it just be dissipated? Through the test, we could find out that cell number 1, with the power supply connected, experienced an occasional current flow through the BMS. On the other hand, cell 4, with the lowest voltage, didn't receive any current from cell 1. It is obvious that this BMS supports passive balancing, which just dissipates the excessive power through the so-called bleeding resistor. Now let's summarize what we have reviewed. This BMS supports 4 cells in series, up to 40 amperes for continuous operation. It is equipped with a built-in overcharge and discharge protection to protect the batteries. Balancing between the cells are only supported while charging. Since balancing isn't supported during discharge, you need to use batteries with similar capacity and characteristics. Also, this BMS supports passive balancing, which dissipates excessive power through the resistor. This can also be another reason for using batteries with similar charge and discharge characteristics in order to reduce wasted power. In the next video, I will introduce 2 types of balancer module, active and passive. This is it. Thank you for watching. See you in the next video.